you need to make it 10 or 12 times bigger than your friend's plane, because you want it to be bigger and better and faster. But you can't lose the proportions of the plane that make it fly as great as it does. So, here's what you guys know. You want your paper plane to be 12 times as big as Miguel's. In order to build this plane, you want to make sure that the wingspans are represented by similar triangles, which means we know the angles will be the same. Setup. On the back, you guys are going to draw a similar triangle as the one on the front of this page that has 5, 5, and 8. You're going to set up the measurements of the wings that will be 12 times larger. Can you flip the page over and find out what these new wing measurements are going to be? Yeah, you do have that. You can draw another piece of paper if you want. I don't know what that is. Oh, that's yours? Oh, yeah. I thought I drew that. Yeah. Here's one. So think about the triangle that I gave you. You know the measurements are 5, 5, and 8. Take about 30 seconds to draw what you think can be the bigger and better plane, knowing that you need to keep it similar. Oh yeah, they can just like draw it. No, I mean this is it's not like like this is just like visualizing drawing a bigger triangle.
So just visualize what you think. I think
like I would just draw a bigger
raise your
one.
hand. Because I was gonna say like how if you actually measured it.
Alright, people are done.
Yeah, sure.
Anyone have an idea of what they would think? Erica, what did you get?
I got 60 and 60, and the base is at 96.
So we started with this little plane that's not very cool. And she made a bigger wingspan. And what'd you say the two?
The two sides were 60, and the base was 96.
What'd you do?
I multiplied 5 times 12, and I got 60, and 8 times 12, and I got 96.
Well, why did you know to multiply by 12?
Because because he said multiply it. It was gonna be 12 times bigger, right?
Yeah. So
I just imagined it like 12 times bigger, and I just multiply 12 times.
yeah. So what? It would still be the same. It should still fly the same, right? It's just bigger, but the ratio is the same. That's what is important. If you just took this and like scaled it down evenly, like imagine on a computer you were just like making it smaller, it would just fit perfectly over this. We didn't change this side bigger and leave this side smaller. You have to keep the ratios the same. So when we set this up, like one side of the smaller triangle is 5, and its corresponding side is 60. Can someone tell me what 5 divided by 60 is on a calculator really quickly?
0.083.
And the corresponding side on the bottom is 8 to 96.
Where's 12?
What is 8 divided by 96?
It's the same.
It shouldn't equal this, right? So we can see that this is similar to this, even though the sides aren't the same. Last class, it was nice and easy because these angles are going to be equal regardless of the size. But now, size is bigger, but the ratio is the same. That is the key point of similar triangles. The ratio of the corresponding sides is the same. Cool?
Cool.
Do we see how that works? Nice. All right, so now we're going to be turning to our guided notes. We're going to go over the key vocab that we're going to use for today. You guys have all seen ratios before, but a nice review. A ratio is a statement of how much of one thing there is compared to another. So what we just did with those triangles, we compared how much there was that little side to the triangle's big side. So a ratio is a part, fill in part over a whole. And we see that of all those little shapes in the example, there are 15 little shapes. The ratio of stars to shapes is 4, which is part of that whole thing, over 15, which is the whole. That's an example ratio. Cross multiply. When a ratio has been set up and equal to another ratio, multiply the numerator of the first times the denominator of the second, which that arrow is 4 times 24, and the denominator of the first, times the numerator of the second, which is 8 times 6. Set them equal, you solve, and we got x equals 12. Similar triangles. Triangles are similar when all of their angles are equal, which you guys just proved in the last class, and their corresponding sides have the same ratio. Just like the plane example we just did, the example on the similar triangle page right underneath that, 4, 5, 6, if you multiply all those sides by 10, you're going to get a triangle with 40, 50, 60, so the ratio will be the same. Cool? Done copying down? Nice, so we're going to turn to the next page and we're going to look at this problem. James, can you read me what the triangle says, or what the directions say? Right under reinforcing key points.
Triangles ABC and WXY are similar. Triangles side and WXY.
All right. Nice, okay, so I think I might not have, I added an extra x under x equals w. You guys see, can you make that 3 instead of 3x? So now we know that xw, the bottom side of that little triangle, is just 3, not 3x. Okay, goal. What is our goal? Well, now we know wx is 3, so now we're just trying to find cb. So our goal is to find cb. Okay, that's 3, that's 7 plus x. Okay, but what do we notice about cb right now? What does cb equal on the picture?
57.
Plus x, 57 plus x? What do we not like about this right here? Yeah, it has that x in it. We gotta get rid of that. So our first goal, though, is to find x, so that we can plug it in and substitute to find CB. So I don't like how these triangles, one's upside down, one's the right side up. So my rule, my first step, is to draw them so that they look alike. So I'm going to redraw this so that B, C, A, all the sides correspond to W, X, Y. So you can write them like that on your page. I haven't changed anything yet. Everything is still the same. I've just flipped it. So now I'm going to attack the problem looking at it like this. You guys are being silly back there. Let's focus over here. So identify sides that are corresponding and set up this ratio. Mr. Lilly in the last class told us how to see what angles are corresponding, but now we can see from my picture here what sides are corresponding. What ratio can I set up here, Tyrion? little more confusing with triangles now instead of just having it written out for your numbers, right? So we're gonna have to look and see this bigger triangle. This side CB corresponds to WX. So we're gonna write 57 plus X over 12, because this corresponds to this. That's our first ratio. And we're gonna set that equal to the second set of corresponding sides, which is B and A, which corresponds to what on this little triangle? John, right here. XW, yeah, because they're both on this bottom right here. And we can tell when they're written ABC, WXY. We can still check to see if they match up. So 45 corresponds to 3. What we put on the top needs to be consistent with this big triangle. What we put on the bottom needs to be with this little triangle. You could also write it 12 over 57 plus X equals 3 over 45. I just flipped everything. We're still gonna get the same answer. Doesn't matter which way you write it. So now we're just gonna cross multiply. 12 times 45, which is 540. 3 times 57 plus X, which equals 171 plus 3X, which equals 540. Doing our algebra, which we all are really good at, we find that X equals 123. So we're done, right? Are we done when we found X? Look back at our goal.
No.
Found X. Now we need to find CB. I know that X equals 123. Alondra, what am I going to do to find CB? We know that CB equals 57 plus X, and we found X. You substitute in the X you just found, 57 plus 123. Your final answer is that CB equals 180. Now, to prove to you guys that we got this right, can someone do 12 divided by 180 on their calculator? Erica, what I get?
12 by 180.
Yeah.
0.06.
0.06?
Yeah.
And what's 3 divided by 45? 0.06. Our ratio stayed the same. I always think it's great to check like that at the end. Just plug your numbers back in. So then we set up 12 over 180 equals 3 over 45. So we got that right. Questions? Did I move too fast? We're going to go through one more that I'm going to go through in the next 6 minutes. We're going to get this problem done in 6 minutes. So if you know it, shout it out. If I call on you, say yes you know it, or no you don't, and we can find someone to help you. Cool. Now, let's see. Josh, can you read the top of that second problem? Nice and loud.
Triangle B, A equals BRO are similar triangles inside BARO.
Cool. So Bay and Bro are pretty similar, right? Come on. Give me some laughs here. So, we have, we have Bay, which is bigger than Bro. It should always be the case. So, Bay and goal here. What is our goal, Caleb? It says right in the question. Read that last part of the question, the second sentence of the question. No, the top part, right under reinforcing. Wait, I think we're. Oh, next page, next page.
Triangle BAE and BRO are similar finally besides BA and RO.
Yeah, so we're trying to find. Yeah, hold on, we'll go through this in a second, and then you can ask your question. So, again, I made another little typo. We are not finding BA, we're finding BR, so fix BA to BR, right here. Cool, so our goal, like Caleb said, we're trying to find BR and RO, but we see in that picture that there are X's, and we don't like X's. We need to find X in order to find that, so our first goal is to find X. Now, up here, I drew them separate. The last problem, I drew them so they were similar, and this time I pulled them apart so you can see it easier. So we have BAE and BRO, and we know that BA equals 78 from the picture, and AE equals 63, so write that in your triangles. BR equals 19 plus X, and RO equals 3X. Now we've got to identify the corresponding sides and set up a ratio. Like our last problem, BA corresponds to BR. So we're going to put one over the other. So we can do, how do I do this? We'll do it the other way this time. We'll do the little one over the big one. 19 plus X over 78. What would the second ratio be, James? What am I setting it equal to? And what do I set that over? What does it correspond to on this triangle? Yeah, 63. Cross multiply. We get 63 times 19 plus X equals 78 times 3X. May, are you following this? Cool. Did I answer it, or are you still got a question? No, you're good, okay. Well, do the math. 63X equals 234X. We gotta move this 63X over here. We want all the variables on one side. 1197 equals 171X. Divide both sides by 171, and we get X equals 7. But we're not done yet. What do I need to do in order to find BR? What does BR equal? 19 plus X, right? So you just gotta substitute in the 7, 19 plus 7, 26. See how I moved this X into this right here because I knew I needed to get a number. I don't want to find a side length in terms of a variable, which means RO, which equals 3X, equals 3 times 7, equals 21. Give me a second to copy that down. Questions? Do we see how to cross multiply, Erica?
Yeah, I get how you cross multiply, but I got confused in the middle of the.
Okay, tell me where. Because if you're confused,
After
then write all this.
finding the I don't know what you mean.
Oh, what I did. You see how I just pulled apart the triangles? I made that big one here, that little one here. So I knew that 78 and 63, and I knew that little side was 19 plus X, and the little was 3X. When we set up a ratio, we'll go over this quickly. We have two triangles that we know are similar. This bigger one and this little one. Say A, B, C, D, E, F. Like Mr. Lilly does, I like writing them on top of each other so we can see what's corresponding here. So say we have 6, 3, 8, and 4. So to set up a ratio, that's what the is about, okay? So we need to find the corresponding sides in order to set up a ratio. We can do this by looking at how, like you said, how they're written. So side, if we know that we're trying to find a ratio, we see that AB is going to be corresponding to DE, because these two are right under each other. So we do AB, which is 6, big over little, or little over big, but I'm doing big over little, 6 over 3. And the second one, we know AC, so A and C, that means those two would have to be D and F. So big, 8, over little, D and F, 4. So drawing this and drawing the triangles aligned and separate from each other really helps me visualize what sides are corresponding. Okay, now we're going to move on to